while to get this. All right, right. All right, so if you look at your formula sheet, the two that we're going to be doing today are actually written in at the bottom. GL stands for Gay-Lussac, which looks at pressure and temperature, and then combined has all three of them together. So those are the two we're going to look at today. So really the main difference with the combined is when you get to that little algebra step, you're going to have to divide by two numbers instead of just one. So that's kind of really about the only difference between them. All right. So let's see if I can get through this today. All right. So Gay-Lussac looks at the relationship between pressure and temperature, and those two are directly related, which means if I increase my temperature, my pressure is also going to increase. And the reason that is, if you increase the temperature, that's like a measurement of the kinetic energy. So if the energy has increased, the molecules or gas molecules will spread out more and they'll collide more frequently with the walls of the container, and that's going to increase the pressure. Because that's how pressure is measured, like how much or how strongly particles are hitting the container that they're in. So my formula for this is P1T2 is equal to P2T1. Your temp still has to be in Kelvin. That's going to be true for all of our gas laws. And if you notice, it says the gas is kept in a fixed container. So that means the volume doesn't change. So that is why volume is not part of this equation. All right. So pretty much, like I said, things that we have already worked with, just looking at two different things. So let's look at a couple of these problems and then we'll put it all together for the combined. All righty. So my first example right here, you're going to need to change that second 0.250 to 50 degrees. A little typo there. P1, T2 is equal to P2, T1. All right. So it says, what is the pressure inside a 0.25 liter can of deodorant that starts at 50 degrees Celsius? So that's going to be my T1. And 1.2 atm, so that's my P1. If the temperature is raised to 100 degrees Celsius, so that's my T2, and I'm looking for my P2. I know it mentions a volume measurement here, but it doesn't say anything about that changing, so that's not going to be part of our equation. So real quick, I'm going to change my temperatures because they're both in Celsius, so I'm going to change them to Kelvin. So my 100 degrees Celsius becomes 373 K. And my 50 degrees, when I add 273 to that, would become 323 K. All right, now I think I got everything organized. So I'm just going to start kind of filling in. So my beginning pressure would be 1.2 amps. My T2, my second temperature would be 373 K. And then my P2 on the other side is what I'm trying to find. And my beginning temperature was my 323 K. All right, so there's my setup. I need to get rid of my 323. So I'm going to divide each side by 323. So that cancels. This is what would go in your calculator. 1.2 times 373, and then come back and divide it by your 323. So really the only other thing you need to worry about is how many sig figs are you going to have? 2, and then what would our units be? ATMs, exactly. So hopefully you got 1.4 ATMs. And the reason it's 2 is because we always go with the least. And that one had 1.2 sig figs. I know the 50 started out with 2, but by the time I changed it to Kelvin, it ended up being 3.
So when you did it in Celsius, you use the sig figs.
when you change it, because that's actually what's going to go into the calculation. All right, any questions on that one? Like I said, it gets a little bit repetitive. At what temperature? We'll look at the next one. Will the can above have a pressure of 2.2 atmospheres? So I'm changing my pressure, and I'm wondering what my temperature would be to have to get changed to that pressure. So everything, my P1, my T1, those stayed the same. So I'm still using my same formula. So my beginning pressure didn't change. So that was my 1.2 ATMs. My T2, that's what I'm interested in. That's my unknown. My P2 was when it changed to 2.2 ATMs. And my beginning temperature, we set up here, was my 323K. All right, there's my setup. So what do I need to divide each side by on this one? 1.2. And how many sig figs will my answer have? Again, has 2 again for my temperature. So what would it be with 2 sig figs? 590K. You would get 592 in your calculator, maybe probably with some decimals behind, but since I could only have 2 sig figs, I need to just put a 0 as a placeholder. So this is how I would want to report that answer. All right, any questions on that one? All right, so the next one combines the things that we've looked at so far. So the only thing that we haven't looked at, which we'll look at on Monday, is little n, which was moles. So we've looked at pressure, temperature, and volume. So we're going to combine those 3, and it's going to be P1, V1, T2 is equal to P2, V2, T1. Just like before, because of the way temperature is related to those other variables, it seems to be like on the opposite side. In other words, T2 is going to go with my P1 and my V1. The temperature still has to be in Kelvin, and my units would still have to be consistent. So like if I had one pressure in atmosphere, I would have to have the other one in atmospheres too. So like I said, kind of the big difference here is at the end, when we do our little bit of algebra, we end up dividing by 2 numbers, multiply by each other. That's kind of your big difference. All righty, we'll just look at the first one. We have a 15-liter cylinder at 4.8 ATMs, pressure, and 25 degrees Celsius. So that's all of my beginning. Liters would be my volume, atmospheres would be my pressure, and degrees Celsius would be my temperature. And that's in Celsius. So when I add 273 to it, I get 298K. All right, and then that is heated to 75 degrees Celsius. So that's what my temperature is changed to, and compressed to 17 atmospheres. So there is my P2. So what is the new volume? My V2 is my unknown. So once again, I'm going to take my 75 degrees Celsius and add 273, and that would give me 348K. All right, now I think we're ready to plug everything in. Just going to rewrite my formula here since I erased it. All right, so we start with P1, my beginning pressure, which was 4.8 atmospheres, times my beginning volume, which was my 15 liters. And then T2 goes with that, so that would be 348K. And then on this side, I have my P2, which was my 17 ATMs, times my V2, which is my unknown, and come back and grab my beginning temperature, which was 298K. All right, my V2 is my X, so that means I need to get rid of 17 and 298. So I'm going to divide it by 17 times 298, and over here I'm going to do the same thing. This will cancel, and then this is what all goes into your calculator on this side. And how many sick days would I have? Two again. I don't know what you did try to do. Yeah, I think you should have got 4.9, right? 4.9 liters. Yes, sir. So did you do 4.8 times 15 times 348 at the top? And I hit equals to like get an answer. And then if you'll do divide, it should bring that number down. And then I would do 17 times 298. You might want to put that in parentheses if you're going to be dividing by it. See if that works. Did that work? Yeah, I can't see that part. Oh yeah, you're okay. So whatever you're doing, let's see, figure it out. I don't know what it does, like the calculator reads the order of operations differently. So let's just 4.8 times 15 times 348, all right? And then I hit divide and it'll carry that number down. And then 17 times 298. That's what's there on my denominator. Get your 4.9. You're welcome. Yeah, were you putting the two things in the denominator like a separate parentheses? Yeah, that's what he was doing too. So do it. That makes it read the order of operation. All right, why don't y'all give the next one a try? Your temperature is already in Kelvin for you. It makes it even easier. So see what you get for the next one using the same formula. Did you figure out what you did? Did you see you got 625?
Oh, no.
Oh.
I was just messing with you.
What'd you get? 594, but you have to adjust for your sig figs, okay? So if we look, yeah, so what would it become? Perfect, 590, and what would be your units? Kelvin, okay, exactly. Yep, perfect, perfect. All right, let's look at the back, a couple of problems, and I need to make a couple of corrections. So on the first one, this is not correct. This should be 100. You have to put this up, and we'll do this one instead of the 105. And the very last one where it says 309K and then 36.3 degrees Celsius, it should just be 36 degrees Celsius. Very last one on that page. All right, I'm just gonna talk a little bit about the first one mainly because it's talking about sig figs. Some people have already taken the quiz and really they're not missing the actual quiz part. It's the sig figs still that make it a little bit kind of a problem on some of these. So let's just talk about this one a little bit. It says I have an aerosol can that has an internal pressure of 3.5 ATMs. So that's my P1 at 20 degrees Celsius. So I need to change that to Kelvin. So it's 20.0. So when I add 293 to that, it becomes 293.0 K. Did I mean 273? What did I add? Yes. To add 273 to it. I got the 293 part right. So the reason that is because my Celsius had one place behind the decimal. When we add my 273, we have to carry that place behind the decimal. Because remember, sig figs, when you add or subtract, is looking at places behind the decimal. In this particular problem, it doesn't end up mattering because that makes this become 4 sig figs and I have something with less sig figs, but sometimes it could. All right, and so that is my T1. The can will explode when the pressure reaches 12 atmospheres. So that's my P2. And what will the temperature be at that pressure? So that is my T2. All right, so now I'm going to fill in my formula because I'm using the Gay-Lussac. So it's going to be P1, my beginning pressure, which is 3 atmospheres, 3.5 atmospheres. I feel like I just need to kind of let this week go. All right, and that's times my T2, which is my unknown. And then I'm going to equal that to my P2, which was my 12 atmospheres, times my T1, which was my 293.0 K. Both of my pressure measurements are only 3 sig figs, so my answer can only be 3 sig figs. So we'll divide by 3.50 and over here by 3.50. All right, so I think you got 1004.57 with some other numbers behind it. So this gets a little tricky because I can only have 3 sig figs. So that's why it's going to end up having to go in scientific notation. The only way I can get this number with 3 sig figs is to put 1.00 times 10 to the third, and my units are going to be Kelvin. Because if I look at my 1004, that second 0 is my third sig fig. 4 is behind it, so I wouldn't raise it up. Can't just put a placeholder because that gives me only one sig fig. So that's why the only way this can be written correctly is as 3 sig figs in scientific notation. So kind of a tricky one. I don't do those on purpose. Sometimes I just happen to come up with a problem that I pull. Does anybody have any questions on that? On the sig fig part? Okay. So y'all got some time. You can practice on these or pull out your Boyles and Charles and ask questions over those. That's what we'll have our quiz over. I'll let y'all work on whichever practice you want to at this time. And ask questions if you have them, please.